Enhancing the authenticity of rendered portraits with identity-consistent transfer learning. We first introduce the motivation of our method. Despite rapid advances in computer graphics, creating high-quality photorealistic virtual portraits is prohibitively expensive. Furthermore, the well-known uncanny valley effect in rendered portraits has a significant impact on the user experience, especially when the depiction closely resembles a human likeness, where any minor artifacts can evoke feelings of eeriness and repulsiveness. In this paper, we present a novel photorealistic portrait generation framework that can effectively mitigate the uncanny valley effect and improve the overall authenticity of rendered portraits. Here are exemplars of photorealistic faces generated by our method. Now we introduce our basic idea. We conduct portrait replacement in the W+ latent space by employing latent code that implicitly represents portrait style and identity as the interface in between. We establish identity-consistent transfer learning on the style GAN generator of realistic portraits G-Real, resulting in a fine-tuned generator G rendering of portraits with the rendering style. The transfer learning is performed in a way that, given a single latent code in the W+ latent space, the portrait identity can be well preserved in both generators. Only the portrait style is interpreted differently as realistic style by G-Real and rendering style by G-Rendering. In other words, the same latent code can generate two portraits with distinct styles but matched identity. During the inference phase, we aim to invert the style of the input portrait from rendering to realistic. We begin by applying GAN inversion to obtain the avatar's latent code in the W+ latent space of G-Rendering. The latent code is then fed into G-Real to adapt to the realistic style while preserving identity. In the end, we achieve the final result, a photorealistic portrait with the identity of the input avatar. Now we introduce our methodology. We first create DRFHQ, a dataset that comprises 11,399 high-quality rendering-style portrait images, by collecting DAZ3D.com's gallery, with a wide range of gender, age, pose, race, and hairstyle. Inspired by style GAN ADA, we initialize G-Rendering using G-Real, freeze the mapping network, then we use DRFHQ to fine-tune G-Rendering, resulting in a new stylized generator G-Rendering capable of producing rendering-style portraits. However, simply fine-tuning the generator leads to large facial identity deviations in the fine-tuned latent space compared to the original. To address this issue, we use two additional losses, sketch loss and color loss, during the fine-tuning process to constrain the facial identity. Specifically, we freeze the G-Real during fine-tuning and input the same latent code into G-Rendering and G-Real respectively. The two resulting portraits are then used to compute our losses. Inspired by deep face editing, the geometric features of the face can be well represented by sketches. The outputs of G-Real and G-Rendering are first down-sampled, then are fed into the pre-trained sketch extractor in the deep face editing model separately to obtain two face sketches, and the geometric contours of the two faces are constrained to be as similar as possible by using the L1 norm. To preserve the portrait color during transfer learning, we propose a color loss at the perceptual level based on the LPIPS loss. Specifically, we first downsample the image and apply Gaussian blur, then feed the images into the VGG16 network to compute the LPIPS loss. Now we show more results of our method. Here we display a variety of results that span various genders, ages, and races, effectively illustrating how our approach can adapt across diverse data sources. The generated faces avoid the uncanny valley effect by largely improving the authenticity of the rendered faces while maintaining the facial identity. Our proposed method can also be applied to improve the authenticity of digital sample display images. Our generated realistic faces can easily blend in with the rendered garment and virtual avatar bodies with only minor post-processing, significantly enhance the overall authenticity of apparel display renderings. We compare our method qualitatively and quantitatively to two lines of research: facial realism improving methods and style transfer methods. We perform qualitative and quantitative experiments to compare our method with style-gone inversion methods, which project unrealistic images onto the manifold of natural images through image inversion. Our method produces more photorealistic results with more natural facial details and effectively removes the input image's unrealistic rendering style appearance while maintaining facial identity consistency. The quantitative experiments are showcased through a user study. Results shows that the vast majority of our results are considered by 20 participants more realistic. We also conduct a comparison with state-of-the-art diffusion-based method, SD-Edit. Our approach stably generates more photorealistic results, showcasing enhanced natural facial details. Moreover, our approach effectively removes the unrealistic rendering style appearance of the input image while preserving the consistency of facial identity. We present a qualitative comparison between the style transfer results of our identity-consistent style transfer method and those of style-gone nada and agile-gone as shown in the figure. Our approach produces rendering style results while preserving face identity. We use two metrics, FID and identity similarity, to evaluate the performance of style transfer, respectively. As shown in Table 1, our style-gone 2D-RFHQ model is better at both style transfer and facial identity preservation. Table 2 also demonstrates that our style-gone 2D-RFHQ model exhibits superior performance in preserving facial identity during the process of style transfer. We also perform 4 ablation studies to validate the effectiveness of different components of our work. We first evaluate the 2 proposed losses. Results show that our proposed 2 losses helps to better keep detailed facial structure, semantics, color and lighting of the portraits generated by style-gone 2 FFHQ model. We then assess our transfer learning-based framework. Results show that our framework can achieve more realistic results than the baseline. The ablation study of inversion methods demonstrate that our inversion method surpasses all others during inference. Finally, both the qualitative and quantitative comparison of datasets validate the efficacy of our high-quality rendering style portrait dataset, DRFHQ. Thank you for watching.